All right. Hello, everybody. Welcome to the first episode of our Steely Motive LinkedIn Live program. I'm George Coates with the World Auto Steel, and my esteemed guest beside me today is Neil McGregor, the Chief Engineer for Ricardo and the Chief Engineer on our program. Good afternoon, Neil.
Oh, hi, George. Hi, everybody. Nice to see you all.
Yeah, well, this is an opportunity for us to give you a high level overview of this very exciting program, again called Steely Motive. We've been working on this program for actually we're in our fifth year already. It's amazing how time has flown. On the screen, you see an overview of World Auto Steel. I'm a technical director with World Auto Steel, which means I essentially am a project manager for the many programs that we assign to engineering institutions and universities, et cetera. And on the screen, what you see is our 18 member companies. We're the automotive arm of the World Steel Association, which is headquartered in Brussels. And as the automotive arm, we've got 18 members representing various global regions, and you can see their logos here. And they contribute funds to our program research. We're a research organization, not a lobbying organization at all. And geez, back in 2019, we issued a series of RFQs to a number of organizations, and we were quite excited to select Ricardo as our partner in this Steely Motive program. At the time, we called it Future Steel Mobility. And we had experienced Neil on a smaller project before, and we were quite excited to find that they were going to assign Neil the chief engineer role for the program as well. So Neil, here we are 5 years
Yeah.
later, right? And
Wow.
of course, the detail began right when COVID hit. But
Yep.
so but we've been kind of married at the hip, joined at the hip for a while now. What's been the biggest surprise to you over these 5 years, over this journey?
Um, well, yeah, firstly, hello, everyone. I'm Neil McGregor, the chief engineer for the Steel Motive program. So I've had the pleasure of being the technical lead on this program. But yeah, in terms of surprises, I think, I mean, the 5 years kind of went by in a bit of a flash, in a bit of a blur. So now we're only at the point where we can actually look back retrospectively on the program. But I think one thing that surprised me was because it was a clean sheet design of an autonomous vehicle. I think one of the things that surprised us and the engineering team was how much the autonomous kind of design freedoms would change the conventional vehicle design. So, when you take away the driver controls, you go to full autonomy. It gave us lots of freedoms, things that we could do on the vehicle that are different to the way that you normally design a vehicle. So that was quite a big surprise to us. Um, but then, and another thing that surprised us is how that impacted the vehicle design, and how we had to kind of manage the crash loads, the front crash performance, the occupant positioning. So it was exciting. It gave us a lot of challenges, and it allowed us to kind of test our engineering skills and test the engineering team and push them to the limits and push the limits of the steel design. So that was kind of one of the surprises. I guess another surprise, again, just kind of looking back, was we came up with something quite novel and innovative, futuristic autonomous vehicle design. But what was a little bit surprising is how applicable though the elements of that design are to modern vehicle design. Yeah, so we're now at a process of kind of looking at elements like the battery structure, the crash structure, and kind of saying, okay, how does that relate to modern sort of passenger car design? And one of the surprising things is how applicable the futuristic design is, and the steel structure design is into current design. And I guess the other nice surprise has been the industry reaction. So we completed the engineering a year, 18 months ago, and then since then, myself and George, as he said, have been joined at the hip on the road, telling the story about Steel Motive at a number of kind of global engineering conferences, and then more recently we've been doing kind of more intimate technology transfers with OEMs and suppliers, and it's been nice. The industry reaction to the project and the design has been quite warming. It's been quite refreshing. So yes, lots of nice surprises at the start of the project, and some nice surprises at the end of the project as well.
That's awesome. Yeah, I love this slide right here I put on the screen. Everybody in attendance can see the style of the vehicle, and I remember when we went through the styling exercise, that was really cool. Mauricio took us through
Hmm.
brainstorming exercises and very innovative shapes, ranging from the shapes of animals and fruits and trees to gorgeous buildings,
Mm.
right?
Yeah, yeah,
And trying to
yeah.
come up with this exoskeleton look for the vehicle. And of course, this was done before we developed the body structure.
Hmm.
But for those who are attending, really, this is our vision, the steel industry's vision for autonomous ride-sharing EVs that we think pave the path to net zero emissions by 2050. And why it matters is because, well, first of all, we did a tremendous amount of research. We used FKA in Germany to help really understand this transformation that was occurring, where OEMs and others were reconsidering transportation instead of the movement of vehicles to the efficient movement of people and goods. And in these studies, one of the key trends was urbanization, people moving back into the cities. And so megacities, 10 million inhabitants or more, were characterized by pollution and congestion and gridlock, right? And then enormous vehicle ownership fees, because just the parking fees alone could be 3 and 4 times the cost of the vehicle. So we were finding that in these large cities, people were looking for new transport solutions. Micromobility seemed to be one that was a really great one. And so in this Venn diagram you see on the right side, comfort. In order to get people to be comfortable with moving from vehicle ownership to ride sharing, we knew we had to make these vehicles comfortable to access, but also really safe. And so and we knew that these vehicles were going to operate at high speed, and you'll see that when Neil talks about some of the targets. But in order to get people comfortable then with the vehicle, we needed to hit all the global high speed crash worthiness standards. And we thought if we did that and then made the ride experience appealing, then it would encourage people to use this type of service, which is necessary to get us to that net zero. Also, we needed to make sure that the ride was affordable from the user perspective, but also from the mobility service provider perspective. And one of the ways you do that is you remove the driver, because that's a big cost for them. But you also, by doing that, and you alluded to it, Neil, you remove the steering wheel and the pedals and the driver interfaces, and now you can put an extra occupant in there, which generates more revenue because they're looking for a profitable business case. And then on the left side, you see sustainability. I mean, we knew, and all OEMs are focused on sustainability right now. What were you doing within the vehicle confines to reduce the CO2 footprint? So we put all those together, and our chairman of World Auto Steel, where they converged, called that future mobility that only steel could make real. So, but anyway, so that led then to the vehicle target setting. And take us through some of these, Neil. I know initially some of the reactions were this vehicle looks quite futuristic,
Hmm.
but what do you think? Did we get them right? So we have
Yeah,
two
yeah.
vehicles. How about if you take us through this?
Yeah, I mean, I think the specifications were pretty spot on. The success, in my experience, kind of the success of a project is kind of in the foundations and the basis. And really, World Auto Steel laid out a really good, solid set of vehicle specifications for us to work with. We adjusted them a little bit and added some more features to them, but essentially the Steel Emotive program comprised of two vehicles, SEM 1, which is the smaller urban vehicle. So you can think of journeys kind of up to maybe 20 kilometers, so like a commuting or a shopping type journey. So SEM 1 is up to 4 passengers. It's got a 75 kilowatt hour battery that gives us 500 kilometers of range. Front electric motor. It's a high speed autonomous vehicle, so it's got a maximum speed of 120 kph. Full level 5 autonomy and just over 1,500 kilos curb weight. And SEM one's pretty small. It sits just below the size of a European C segment. So that silhouette in red that you can see there is a VW Golf. So it's quite a compact vehicle. So that's SEM one, and we did most of the engineering development on that. So most of the 3D CAD design and simulation was done on SEM one. Later in the program, we worked on a derivative, a variant of SEM1, a stretched wheelbase variant, which we call SEM2. This is for longer journeys, so maybe going from city to city or longer commutes or to the airport. Suitable for up to 6 passengers, slightly bigger battery to give us the range. And we aim for maximum commonality, so it's got largely carryover front and rear structures to SEM1, with a unique center section for the stretch wheelbase variant. So these were kind of the basis of all the engineering development that we did was based on these two vehicles. And like I say, it's proven to be pretty spot on. Like I say, most of the industry reaction has been very positive. In terms of the sort of potential application of these vehicles, again, we've received very good feedback about the suitability. So yeah, I think a really good solid set of vehicle specifications there.
Yeah, thanks, Neil. We also involved several OEMs and mobility startups, a couple disruptors in what we called an advisory council early in the program. We met with them a couple times, and I remember on SEM1, the urban variant, the 4-passenger vehicle, one of the OEMs said, "Wow, it's awful small, right?"
Mm.
And an Asian OEM said, "Maybe not small enough," right?
Yeah, I remember that.
So,
Yeah,
so that was really great to get that experience from these organizations because they knew,
yeah.
a mobility service company wasn't going to have own 10 of these. They were going to have 100 of these parked along a curb, and their goal was to get people in and out quickly.
Mm.
And certainly a small vehicle would help them meet that mission. So, yeah, that was really great.
Yeah, yeah.
Um, here's the body in white. So the steel industry, our members, our 18 members, did a great job of compiling their product portfolios and submitting their advanced high-strength steel grades to this portfolio, which ended up numbering about 64 distinctly different grades. And I think 18 of them made it into the primary bill of materials. How about if you can speak to a little bit, you can see the distribution of the materials
Mm.
color coded to that body structure, but you've worked with a lot of
Mm.
different materials. Was steel an enabler here to the performance targets that we hit? How did it help you?
Yeah, I mean, with any vehicle design, you're faced with a number of kind of challenges. So you've got to meet cost, you've got to meet weight, stiffness, strength, durability, safety. So you've got a lot of requirements to achieve in a vehicle design. And then with any design, it's about putting the right material in the right place. And then having 64 grades available to us allowed us to kind of select from that the grade that gave us the right strength, the right stiffness, the right cost. So it really gave us, it was a really fantastic kind of toolbox, we called it, for us to work with. So having that kind of that portfolio of grades was extremely helpful to us, and the support from the members, the steel suppliers in the project was absolutely fantastic as well.
Awesome. And then these are what we described as our 7 key steel innovations. I know we're not going to have time to get into this today, but with time, we expect to have several different episodes where we'll pick a few of these and focus on those. Any of these that in particular delighted you, Neil,
They
or were a challenge?
they all delight me every time I see this slide. It's great. It's a great. There were some. I mean, yeah, there were some great innovations that came out of Steelomotive, and these are just a sample of them. I mean, the previous slide showed the body in white, the body structure. That is in itself an innovation. It's primarily, it's fundamentally designed from the ground up for an autonomous vehicle, and there aren't too many of those around at the moment. We had to think a lot about the passenger protection zone, and around that for an autonomous vehicle. It's a small vehicle, so and small vehicles don't like to crash very well. We don't have very much space to crash, so The front crash structure is particularly innovative. There's a couple of features in there that we christened the glance beam. That's a specific component that helps us achieve the crash. You can see kind of the doors that we've got there. We call them a scissor door. They're kind of mounted on central hinges that give us a good door aperture width to allow the occupants to get in and out quite easily. The hex beam is like a roll stamped steel component that goes in the rocker, almost like a series of crush cans that give us good energy absorption for side crash. And then the battery carrier frame, so it's fairly innovative. We deleted the cover, the top cover, and the side cover from that. That gave us some really good cost and weight saving for the battery housing. So there's a load of innovation in there, and I don't want to give too much away, but we will do more of these episodes and look into some of these innovations and reveal a lot more detail about them. So yeah, we'll cover that off in a couple of other episodes, I think, George.
Yeah, that's awesome. And in particular, some of the front crash requirements took us on a journey all the way to
Yeah.
IHS in Virginia, which was really interesting, and we'll be able to talk about that in one of the future episodes.
Absolutely.
Yeah.
Absolutely.
And then I think just for today, let's end on this slide. We know that all OEMs and suppliers are really focused today on sustainability metrics and what are they doing to reduce their carbon footprint and the contribution of their material to the CO2 footprint of the vehicle. So this is just a summary slide looking at sustainability from a life cycle perspective. We understood that in all phases of the life cycle and in all factors that are contributors to the overall footprint of that vehicle, we needed CO2 reduction strategies. And so we took those to heart and we were bullish on that. And as a result, I think we've been able to show a potential for about an 86% reduction in CO2 by 2035. And our deployment of these vehicles is estimated to be in that 2030 to 2035 timeframe when we'll really see mobility as a service, autonomous EVs launched in high production volumes. So we use that as a target timeline for our sustainability improvements, and we'll share those details. I think we'll have one of these episodes fully dedicated to sustainability. Yeah. So with that, I want you to know that there's a full engineering report that's available to everybody for download. I think we can perhaps show the link for that in the chat here. Make sure that you follow us on LinkedIn Live. We'll be streaming another chat soon. And Lori, you want to have any closing comments for us?
Sure. Hello, everyone. I'm Lori Jo Vest, and I manage social media for World Auto Steel. So I'm going to wrap us up today. As soon as we're done, I'm going to drop the link to the free engineering report download into the comments. So you can go grab that wonderful piece of information that's got all kinds of details about the project. And keep in mind that George and Neil are both on LinkedIn. They're open networkers. So if you have any questions, you can leave them in the chat under this event, or you can connect directly with George and Neil to get your questions answered. So thank you so much for joining us today. George and Neil, social media managers always love LinkedIn Live events. So you're making me really happy being here, and I really appreciate it. And we'll be back with hopefully several more of these over the next several months. So thanks again, guys.
Great.
Take care.
Thank you very much.
Thanks everyone.
Bye-bye.
Bye-bye.
Cheers. Bye-bye.